Thank you everyone to join this session. My name's Yi. I'm from Arm Shanghai team. And today's topic is DPDK on Arm64 status review and our plan for development and collaboration. So this slide was prepared by my teammate, Herbert, but unfortunately he cannot join the Connect, so I will present on behalf. In any question you want to, may drop a mail and we will answer your mail. Thank you. So I will start. So the first slide was a DPDK project overview. So DPDK stands for Data Plane Development Kit. So it was consisted of a set of libraries and drivers for fast packet processing. And it runs almostly in Linux user space. So the project was started on Intel architecture, and it is now extended to IBM and also on ARM architecture. So below the logos listed all the major members and the contributors. So we have several active members, our partners working on ARM platforms. And also ARM is one of the golden members in the DPDK project. So this is the DPDK project overview. So this slide shows how DPDK is being used. So the use case. DPDK framework provides many components on which the network applications can be built. So the below diagram shows an application stack that DPDK was involved. So from the diagram, we can see that DPDK majorly serves as a user space packet I/O driver component for the whole application stack. So it provides the user space pool mode driver for the hardware packet I/O. So above it, we can have a soft virtual machine switching layer, which can be provided by the Open vSwitch or the VPP project for the virtual switching. And also above that is a software protocol termination layer, which we can use, for example, the VPP host stack to serve as a stack termination layer. So on the top layer, there is a variant applications running upon. So this is the use case that our team is currently exploring. And we use DPDK measured as a user space packet I/O component. So this is for the use scenarios. This slide gives a status update for the DPDK project on Arm64 platform. We have multiple active members working on DPDK project on ARM platforms. So especially many thanks to Kevin, which initiated the ARM platform porting for DPDK project since 2015, and after then remain as an active maintainer for ARM platform. So for our team, currently we are majorly working on 3 topics for the DPDK on Arm64. So the first topic is functional verification and enabling. Currently, we are enabling the DPDK test suite on the ARM platform in both the bare metal and the virtualization environment. And on several ARM platforms with selected NICs. So this is the first topic we are working on for functional enablement and verification. The second topic is DPDK performance measurement on ARM platforms. So we can see on the right side This diagram depicts our setup for DPDK performance measurement. We have a bare metal environment which using an X-share traffic generator and using physical NIC. Oh, sorry. And upon it, we run the DPDK layer 2 forwarding application to measure the performance. So this is the second topic we are working on. And the third topic is use case setup. Currently, we are exploring the DPDK use cases in containerized environment and with like Nginx with DPDK and MTCP user space stack. So this is the third topic we are working on. So on the next 3 slides, I will go into details on each topic and give some more information on our status. So the first topic we are working on is the functional enabling and the DPDK test suite. So currently, we already run the DTS, the DPDK test suite on our variant ARM platforms. So all the test suites were executed, so including the virtualization suites. And while we are doing this enablement, we have upstreamed more than 60 patches to the DPDK and also the DTS project. Our purpose, our goal is to identify a set of DTS test cases suitable for ARM platform so that by enabling and by passing those test cases, we can ensure that DPDK is properly supported on ARM platforms. But due to some resource limitation or some priority, we will not fix all the DTS issues. So still some failures are low priority or we do not have that hardware. So also we are working on set up and CI for the DTS to run automatically. And totally there is around 200 test cases passed out of the around 400 test cases. So we are continuing work on this enablement and the CI setup. Yeah, so next slide shows our internal DPDKCI setup. So the purpose is that we can get ready for upcoming some public DPDK lab and make sure that DPDK always work on ARM platform. And also the DPDKCI setup can serve the purpose for internal patch review and for daily build. The status is that we have 2 selected platforms enabled for the DPDKCI internally. And we are running the DTS unit test suite on our internal DPDKCI setup. Our next plan is that we can add more test suites besides the basic unit test. And we can extend or copy this setup to the Linaro lab with proper hardware. On the right side, the diagram just shows our internal DPDKCI setup. We are using Garrett and Jenkins to manage our DUT and tester computer or tester server. Okay. So this is for internal DPDKCI setup. Okay, so this is the second topic we are working on for performance measurement and optimization. Now we already run the RFC2544 test suite in our internal CI setup. And we are continuing collecting the performance measurement, especially for the throughput and the latency data. So on the right side, you can see that we are collecting the throughput and the latency data, and each bar represents a throughput number on different platforms. Through this performance measurement work, we are preliminary identify some factors which will impact the DPDK performance on Arm64 platforms. So one factor is the TRX descriptor number. So by configuring the TRX descriptor number, we can increase the throughput performance. And also we identify that glibc and GCC version can impact the performance number. So newer version will be better because, so this is a good thing that we realize that glibc and GCC are continuing optimization for the Arm64 platform. So also we identify that some Arm platforms show better performance than x86 platform on some specific test cases, like memcopy and OpenSSL-AES. So this already shows some benefit of the Arm64 platform because of a special hardware accelerator for those functions. Finally, we also run some profiling to measure the CPU cycle hotspots on Arm platforms. So this is only some preliminary investigation, so we will continue on this profiling works. So this is the second topic for performance measurement. So this is our future plan for DPDK work for Arm team. It was in 4 categories. For functional enablement, we will move on to some use case, especially for the virtualization scenarios investigation. So currently virtualization and containerization is quite hot topics. Also, we will continue on the CI setup with a selected platform, and also will collaborate with Linaro LEG team for the DPDKCI automation. Also, we will continue work on the architectural enhancements for the DPDK on Arm64. For the roadmap, we will define the DPDK on Arm roadmap with partners and with Linaro together. For the performance measurement and optimization, we will continue work on the bare metal environment. But also we will start working on the virtualization scenarios. And we'll investigate and optimize on the like PMD crypto drivers, such component. And one topic is to investigate the performance in virtualization and multi-core scenario, because Arm was said to be will benefit on multi-core architecture. So this is for performance. And for the community collaboration, Arm team will co-work with Linaro on DPDK, and will build up connection with the DPDK community and our partners. So this is the community collaboration plan. Now we have an internal CI setup, and we will work with Linaro to have the DPDKCI setup in the Linaro lab. And we will regularly sync up inside Linaro for the DPDK directions and future works. And the third one is a proposal to establish a contact channel or mailing list to coordinate on the DPDK work in Linaro. Okay, so this is all slides for the DPDK on Arm64 platform. So any question?
So, is this on? So, Yi, on the one slide where you showed your DTS failures, there's a slide that was breaking down what the failure analysis. Yeah, that one. So the failure, that's it. So I'm trying to, it's a little small to read that pie chart, but this is the breakdown of, so it looked like roughly half of the tests were failing, and these are the reasons why they were failing.
Yeah.
So, so the one of them is problems with DTS itself as opposed to with ARM, or could you just elaborate a little bit about those failures that you were able to identify?
Yeah, so for the bug, I think it is simply that this test case have a bug on ARM platform. So for the NIC, it majorly means we are short of hardware. So some NIC hardware was not available in our lab. And for the DTS and the Intel only, so Song, can you elaborate on this?
Actually, no, DTS was initially designed by Intel. So some test cases actually is bind to their hardware, some feature on their NICs. So it's not good design for multiple architecture. I talked with some Intel people too. But this is what they have in DPDK for now. So for some test cases, it may not be relevant to ARM yet. So I think the more important thing to identify and select test suite. So we can ensure DPDK is well supported on ARM. The problem now, there are no public DPDKCI. Intel have internal CI system. So when they saw the problem, something is broken, they just send email from the CI to the project administrator. But now, they are initiative and committed to set up DPDKCI in DPDK Open Lab. It's still in progress. So a lot of things happening in the release state is some people, they only have Intel platform, they do some code change, actually it's make the ARM build broken, but they don't know. So actually this one is quite important. I think Linaro can help together how we can set this up for DPDKCI or ARM. We still have some work to do.
Yeah, I agree. I mean, so my understanding was that DTS was originally designed to test x86 platforms for ability to run DPDK, right? And obviously with DPDK moving to add ARM support, it sounds like DPDK got ahead of DTS in that.
Yes, exactly, you are right. Actually, there was some discussion on what kind of test suite we should use for CI. The problem of the DTS is currently what people have. And ARM, I think AXP or Kevin and some other partner already done some work to fix some issue. Another option is to develop a separate test case just for ARM. But eventually this idea was rejected. Now people align we should move on DTS, but make it more suitable for multiple architecture. But for ARM platform, we still have a lot of things to do.
Which hardware do you use for testing? Is it Arm64, but do you use NICs or do you use some, I don't know?
Actually, in our lab, we have mixed kind of ARM hardware. We have Huawei D05, D03, we have Qualcomm, we have NXP hardware, we have KV1, we have soft iron. The NIC we are using mainly are Intel NIC and Mellanox NICs.
And do you receive line rate speeds on ARM also?
Excuse me, could you repeat again?
Do you get line rate speeds for Mellanox NIC on ARM64?
For the test with the Mellanox NICs is still in progress. We used the Intel NIC first. The reason is that we saw some PMD performance issue. We did some performance tuning for Intel NIC driver on ARM. For Mellanox, we are working on that. We don't have like a performance report yet. We achieved line rate on some NICs, on some ARM platform.
Okay, so PMDs do need some work to work perfectly on ARM, right? So it didn't work just out of box.
Yes. For some NICs, it may take some time. It may not work on well. We fixed some issue for Mellanox work with Qualcomm. But I think not all Mellanox NICs can just work on some ARM server well for now, because ARM server for driver side, there are always some problem. There are some hiccups. We are trying to fix this along the way during our testing.
Okay, yeah, that's interesting. Can you share some details, probably? What kind of fixes are? Because PMDs are written in C, right? So you compile C code on x86 and on ARM. And after that, you also need some fixes on ARM. What kind of changes are needed?
Okay. The thing is, the one like problem we fix in Intel NIC is some part of driver code. Actually, I have to say I don't remember the detail. It's the engineer from our team did the work. Okay. If you need the detail, you can drop me the email. I can like give you more detailed instruction on what we have done.
Yeah, okay. I just asked if some common changes like prefetch or something, if you remember what,
yes.
what is it?
Okay. Normally after we fix a problem, we just upstream the patch. If you like see some problem, you can ask us too. Probably for something we have taken a look already. It's still like I agree for some NICs work with some servers because we haven't tested all the scenarios. Sometimes have problem.
By the way, do you use little endian or big endian or both?
You mean the NICs?
Yeah.
Oh, I'm not sure. Like, do we care about NICs? Should be. I think we just little endian. Should be little endian.
Okay.
Okay.
The optimizations are, just to answer part of your optimization question, most of the optimizations are related to memory ordering, and a few of them are related to the branching.
There have been also some new related optimization in the code, like memory copy is one of them. Yes.
Thank you.
Can you elaborate a little bit more on your software and hardware setup for the CI and the performance testing? I mean, what does your lab look like? You've got a range of different platforms. How are you connecting things up? And how are you controlling the tests?
CI, I think just the one you just this one.
So basically, we are building this CI based on the Garrett and around the Jenkins. So Jenkins will control the test equipment through the control node, and so we can trigger the data build through the Jenkins jobs. So it will, the job will be scheduled to one specific configure node and run with both the tester to generate the traffic and with the DUT for the specific test case. And also, besides the data build goes through Jenkins, we also can trigger the manual build through the Garrett For example, we have a code review. We have some patch submitted into the code review system, and it can trigger a build job through Garrett to the Jenkins and run automatically on a specific configuration. Yeah.
So you've got a set of static configurations that you're using for testing?
Yeah. Currently, each configuration is static and specific for several test case scenario. Yeah.
So have you got things, machine just wired directly together, or are you going through switches, or?
Yeah, currently all our traffic goes through a 10G switch. Yeah. And this switch is dedicated for the lab use and isolated from the company.
Okay, thanks. So, actually, a little bit more on that. I'm interested. I'm with the Lava team,
Great.
and so we're looking at doing some more of this type of testing. So, do you isolate your tests, or do you only run one at once, or what's the scheduling look like?
For the scheduling, I do not know the detail for this. Yes, because the system was maintained by our IT team, so we are with their help to set up this specific configuration and the Jenkins jobs for this.
Okay, thanks.
Okay, thank you for the question.
Okay. My question is because we know the SPDK, SPDK is for storage domain, is based on the DPDK. So my question is, all the optimization and architecture enhancement is transparent for SPDK if we use SPDK based on the DPDK?
Yeah, so currently we are working only specifically on DPDK project. So the investigation and optimization is focusing on network application. So I think for SPDK it will have a special requirement or a different measurement for the storage application. Yes.
Actually, we have an engineer work on SPDK. There's a talk, maybe it's at the same time with this talk on SPDK.
Yeah.
So you can talk with an engineer from our team directly.
But they just based on the DPDK. So my doubt is if we enhance or modify the DPDK, they should synchronization with this base version, or maybe it's transparent. It's no need to do this synchronization.
I think so, but probably SPDK use some stable release from DPDK. That's usually the case. It should be transparent, and every improvement we do here, you will leverage from SPDK.
Okay.
Yes.
Thank you.
Our team also have some plan. You can talk with the engineer on the SPDK progress.
Okay, I know.
It's part of Linaro. I'm not sure part of Linaro enterprise group work, or it's just from our team. You can talk with them.
Okay, thank you.
Okay, so thank you everyone. So it's just in time. Thank you for joining the session and have a good day.